Hi, my name is Dash, and I'm a full-time model here at Snowflake. That is actually not true. What is true, though, that today I'm going to show you how to build image recognition applications in Snowflake using Snowpark for Python, PyTorch, Streamlit, and OpenAI. Now, before we get started, I just wanted to highlight a couple of things. Snowpark allows you to write data applications in languages other than SQL. One of them being Python, which is what we're going to focus on today. Streamlit, on the other hand, is a pure Python open source application framework that allows you to write these apps that are web-based without you actually knowing anything about HTML, CSS, or JavaScript. PyTorch is one of the most popular open source machine learning frameworks that also happens to be pre-installed for you to use in Snowpark for Python via Snowflake's Anaconda channel. Now, before we get started and look at the code, let's review what you're going to build and what you'll need to build these applications. You're going to build two web-based image recognition applications in Streamlit. The first application will allow the user or yourself to upload an image. And then the second application will use OpenAI's DALL-E 2 to generate an image based on user input into the form of a natural language, if you will. And more importantly, in both applications, the Snowpark for Python UDF that uses PyTorch for image recognition running in Snowflake is exactly the same, which is pretty awesome. You can reuse code. Now, before you can create these applications, what you'll need is a Snowflake account. You'll also need to create a warehouse, a database, and a schema. And optionally, create an OpenAI account if you want to run the second application. Once you create an OpenAI account, you'll need to generate an OpenAPI key. All these details are highlighted in this quick start. And just follow these links if you need more help. Now let's look at the applications a little bit more in detail. Like I mentioned, there's going to be two applications you're going to build. The first one will allow you to upload an image using Streamlit's file uploader. Once the file is uploaded, the data, basically the image data, is converted from base64 into hex. And that image data is then stored into Snowflake using Snowpark API, write pandas. Second application will allow you to generate an image using OpenAPI's image create API. The rest of the things are pretty much the same, where we convert image data from base64 to hex and then create a new file name for it and store the data into the Snowflake table using Snowpark Python API, write pandas. Now, in both applications, for simplicity, the hex image data is stored in string format in a Snowflake table. And the Snowpark for Python UDF that uses PyTorch for image recognition running in Snowflake is exactly the same, like I mentioned before. And this is how it's invoked. Okay, so for this particular application, we're going to use PyTorch implementation of MobileNet v3. And I really want to thank the authors for the research and making these pre-trained models available for us to use. Okay, so before we can use these pre-trained models and the associated files, we have to upload these to a Snowflake stage, which can be done really easily using this session.file.put API. And then once we have these files available on a stage, we can add those as a dependency on the UDF using session.add-import. And here are all the packages that we want to use in our UDF. These packages will be automatically installed on the server side when the UDF is registered. And here's the code that actually takes in image data, processes it, and generates a label. Now let's see how you can get started. The very first thing you would want to do is clone the GitHub repository. Once it's cloned, then you need to create a Python environment with Python 3.8. You can use Miniconda or any other tool that you may be using already. Now let's assume that I have the repo cloned on my laptop. And here are all the files. Now the second thing that needs to happen is you need to create an environment with Python 3.8. In my case, I'm using Miniconda, but you can use other tools that you may be using already in your environments. Let's go ahead and create one using Conda. Okay, this will take a couple seconds. All right. Okay, a few more seconds. And what we're going to do next is basically install all the libraries that we're going to need from Snowflake's Anaconda channel. Let me go ahead and copy and paste that. Have it ready. Actually, first, we're going to activate the environment we just created. Okay, so I'm going to copy this and have it ready for us. All right. Okay. The next thing we're going to do is install all the libraries, which includes Snowpark for Python, Pandas, Streamlit, Notebook, and Cache Tools. This will probably take a couple more seconds than creating the environment, but it should be pretty quick. While that's going on, let's see what else we're going to install. We're going to install UUID for creating unique file names for the images that are uploaded, and also OpenAI for the second application where we're going to use OpenAI's APIs to generate images for us. Let's see what the status is. Okay. All right, let's go back here. Once everything is installed, the next thing that needs to happen before you can run these apps is update the connection JSON with your Snowflake account details. So the details that you're going to need are account, user, password, role, warehouse, database, and schema. Like I mentioned before, all the links are provided in the overview section for you to create these different objects in Snowflake. One important thing to remember here is for the account parameter, specify your account identifier and do not include snowflakecomputing.com. The domain is basically automatically appended when creating the connection using Snowpark for Python. And then the only couple other things that you're required to create in your Snowflake account are the table called images with two columns, file name and image bytes, and another object, which is actually a stage called --files in my case, but you can have this named for whatever you'd like. Now, this stage is where we're going to store our model files. All right, so it looks like everything's been installed. Let's go back to the quick start. All right, now we're going to build and run these applications. Now, before we do that, let's go ahead and create these two objects. The first one is images table, and then the second one is a stage. Okay, so I'm going to copy this. And then in Snowsite, paste, run, and copy this. And then run. Okay, cool. Now let's see what's next. All right, so assuming that you've cloned the repo, the next thing you need to do is open the notebook in your choice of IDE. In my case, I'm using Visual Studio Code. And then the file is actually linked here, which points to the same repository that we looked at earlier. Okay. All right, so let's go to Visual Studio Code. Okay, so here's the file. Now, here, what's happening in the first cell is we're importing all the libraries that we need, including Snowpark for Python. So the very first thing we want to do here is switch the Python kernel to the environment that we just created. And then we're going to run this cell. Now here we're importing all the libraries that we need, including Snowpark for Python. The next thing we're going to do is establish a secure connection to Snowflake. Now in this case, I'm using connection JSON to provide all the credentials, but you can also use multi-factor authentication, OAuth, Okta, or single sign-on. And all of these details are really highlighted in our documentation. Now, once we've established the connection, the first thing that we want to do is upload the model files to our Snowflake stage. So I'm going to go ahead and run this cell. And here are the three files that are being uploaded to a stage that we created earlier. It'll take you a few seconds. And then to deploy the pre-trained model for inference, we're going to create and register a Snowpark for Python UDF and add the model files as dependencies using add import. We're also going to add these packages that will be installed automatically when the UDF is registered and executed on the server side. Here's the Python code that will basically load the model, the files associated with it, as well as convert the image data from hex into an actual image that can be used with these libraries right here. And here's the function that's been registered as a UDF using add UDF decorator. So this UDF will take image bytes in string format, which is what is being stored in the Snowflake table, and then process the image, load the model, and give us a predicted label. And this is the function that's being called from the Streamlit applications that we're going to look at next. So the first one will have the user upload an image. So up here, you'll see we're importing all the libraries that we need, including Snowpark for Python, Streamlit, and everything else. At the top, we're setting the page config using st.setPageConfig. We're writing some headers, captions, and things like that. This function right here will create a session, just like we did in our notebook. Once the session is created, the user will be presented a way to upload the file. Okay, and then this is the same code that we looked at earlier, where the image data is being converted from base64 to hex, generating a new file name, and then writing the image data to our Snowflake table using session.writePandas. Once that's done, we're calling image recognition using bytes UDF that we just created in our notebook, passing in the image bytes and the file name as our where clause. This will return a predicted label, which is then displayed on the web browser. Okay, so let's go ahead and run this application. Okay, so I'm going to go ahead and open a terminal window. And the very first thing we want to do is activate the Conda environment or Python environment that we created earlier, so we have all the libraries we need to run these applications. So Conda activate Snowpark grec. And then running these applications is as simple as running this command, Streamlit, run, and then give it the file name. Snowpark, PyTorch, Streamlit, upload. And then this is going to open up the browser window automatically and load the application for us. There we go. Okay, so now let's go ahead and upload a file and then see what happens. There we go. So here's the image that we uploaded, and this is the predicted label. It's pretty cool, right? Awesome. So I'm going to close this one out, and then we'll try the second app. Control C, and then let's look at the second application. I'm going to minimize this, close this file, and open the second application. Again, here we're importing all the libraries we need, including Snowpark for Python, Streamlit, OpenAI in this case. And then it's assumed that you have OpenAPI key generated and stored in an environment variable. Okay. All of the other things that you see up here are very similar to the other app. We're just setting up the browser page, also adding some headers and captions and what have you, and then creating the session just like we did earlier in the first app. And down here is where we call OpenAPI's image create to basically create an image for us in real time based on the text that we're going to enter in a text box in a natural language format. Once that happens, everything else that follows is very similar to the first application, where the base64 image data is basically converted into hex and then generate a new file name, store that data in a Snowflake table. And we're calling the exact same UDF as we did earlier. Now, one big difference here is we're also writing the image file locally using the data that we've generated so that we can actually display that image in the web browser. So that's one of the bigger differences between this application and the first one, besides calling this API to generate the image. All right, and then once we get the predicted label, it's being displayed here, and then we go ahead and delete the image file that's stored locally for us to display in the browser. All right, so let's go ahead and run this application now. Again, Streamlit run, and the name of the file in this case would be Snowpark, PyTorch, Streamlit, OpenAI image rec. Here we go. So what we're going to do here is enter some text in natural language format, and then we'll see what OpenAI generates for us. Okay, so let's say cat playing in sand. Voila, there we go. So this image right here was generated based on our text that we provided by OpenAI's DALL-E 2. And then here's the predicted label from Snowpark for Python. Pretty awesome, right? It's pretty cool. Okay, so let's go back to our quick start guide. So everything that we just did and saw is outlined here. So you don't actually have to memorize anything. Basically, if you just follow these steps, for example, down here, we're saying in the terminal window, run this command, and it will launch the first app where you can upload a file of an animal. And here's the second application where you run this command to run the second app. And as far as the code files, they're all linked in this quick start. So you don't actually have to guess what's in these files. This is the same repo that you would have cloned. So you should have all the code. And on this page, you'll find resources not only for this quick start, but also other examples that we have in our Snowflake Labs GitHub repository. For example, Python demos, developer guide, API reference, Streamlit docs, and also machine learning with Snowpark for Python. That's all the time I have today. Thank you for watching, and I'll see you next time. Dash out.